Hello everyone, let's see this question. Two balls A and B are simultaneously released on two frictionless inclined planes from the positions shown. The inclined planes have equal inclinations. The balls pass through a particular horizontal level 12 second and 4 second after they were released. Okay, so there is some horizontal level through which both the balls pass through at some time, and the times are given. It is 12 second for the first one and 4 second for the second one. How long after they were released will they be closest to each other? So we have to find the time at which they will be having minimum separation. Now imagine this in the frame of one of the balls. Okay, so what is happening first of all is that this is going to slide with g sine theta, and this is also going to slide with g sine theta, but in the other direction, right? Now what? Now the relative acceleration that we would get. Okay, so relative acceleration would be what? It would be a1 vector minus a2 vector. Now a1 vector is g sine theta this way, and a2 vector is g sine theta this way. So when we do minus a2 vector, we would get this, right? So that means what? The relative acceleration will be this way. Is that okay? So this is g sine theta, this is also g sine theta, and this angle is theta, then only it is g sine theta. So how much will be the magnitude of that relative acceleration? The magnitude of that relative acceleration will be nothing but 2g sine theta cos theta. This will be the relative acceleration. So in the frame of B, what will happen? A, which is some distance away, let's say delta S away, it will appear to move along this straight line, you know, because relative acceleration is this way. It will appear to move along this straight line with how much acceleration? This much acceleration. Okay, so when will it have minimum separation? When it is perpendicular, right? So at this point it will have minimum separation. So we have to find the time at which that happens. So the time at which that happens will be delta S cos theta. Distance has to be traveled, and this distance is being traveled with how much acceleration? With this much acceleration. So we know half at square is equal to delta S. So in this case we'll get this equation. So we will have what? We'll have t square is equal to delta S cos theta divided by half into 2g sine theta cos theta. Is that okay? So this is the value of time. Okay, now how do we get this value? How do we get the delta S by g sine theta value? So we know that this from here till here it takes 12 seconds, and from here to here it takes 4 seconds. So if we imagine this B would have slid along this, then it would have taken 4 seconds to go from here to here. So the distance, the difference between these two path lengths, this one and this one, would be how much? It would be uh, half into g sine theta, g sine theta 12 square minus 4 square, right? Half into a into t square will give you this length, where t is 12, and if you keep t as 4, you'll get this length. So this delta S that we are getting would be this much. So let's substitute that here. So let's substitute that t square is equal to delta S upon g sine theta. So delta S upon g sine theta comes out to be how much? 12 square is 144 minus 16, which would give us 128 divided by 2, which is 64. So substitute that value at 64, and hence we get time as 8 seconds. Okay.